Hello and a warm welcome friends to the chapter of Quadratic Equations. In this chapter, we are going to learn a plethora of things right from the basics of a polynomial function which we have learned in the previous grades of 9th and 10th standards. So let's have a look at the index of this chapter, and here it goes. It is going to start with a polynomial function and a quadratic polynomial. Then we are going to dive into the remainder theorem and factor theorem quickly, which were a part of the 9th and 10th grades. And then we are going to learn about a quadratic equations, roots of a quadratic equation, the graphical analysis of them, the nature of quadratic equations, and so on. There are many concepts which we have to learn, new and interesting concepts about a quadratic equation. Once all the conceptual understanding is done, we are going to learn about a few tactical problems, how to approach conceptual problems. Then there are some more solved examples of the mains and advanced type. And lastly, we are going to end with the JEE mains and advanced questions of previous years. So this is a brief index of what all we are going to learn in this amazing chapter of quadratic equations. So now friends, let's start with the very first topic of this chapter, which is polynomial functions. Now, before starting that, let me tell you why are we starting with polynomials in the chapter of quadratic equations. Firstly, we know that JEE is an exam which is very famous for conceptual tricky questions. Each and every question which we come across in the JEE examination naturally is a conceptual question and at the same time is quite tricky as well. What that means is every question has a hidden trick, and to click that trick, that one trick which will solve the problem, your basics, your conceptual fundamentals have to be very clear. And for this chapter of quadratic equation, polynomials is going to set the base, which is the very thing which we have learned in the 9th and 10th grades. So first of all, let's understand how a polynomial function is classified. We have learned that in our previous grades that there are three different classifications that we can do in a polynomial function, right? A polynomial function, firstly, can be classified in the terms of number of variables. So let me write that down. The first classification is on the basis of number of variables. I'll quickly give you a few examples. Let's say we have a equation x square plus 2x. Rather, this is a polynomial. I won't call it an equation yet because equation is something where there is an equality sign, which we are going to deal with after a few things. So firstly, this is a polynomial function. You can write this as f of x is equal to x square plus 2x. Equality with an unit will lead to an equation, equality with a value. Now it is a polynomial expression. You can say x square plus 2x is an expression, is a polynomial, and right now it is a monovariate polynomial because we are classifying this polynomial only on the basis of number of variables. So this will be a monovariate polynomial. Now why is that? Because there is only one variable and the variable is x. Now if I write this polynomial, if I write a new polynomial, let's call this f1x, let's call this f2x. So this is another polynomial, and if I write this as x plus 3y square, you can just write this as x plus 3y also, x plus y as well, to make it as simple as possible. Now this will be a bivariate polynomial. Now why is that? Because this polynomial has indeed two variables. One of them is x, another of them is y, and that is why it is a bivariate polynomial. Now just to enhance on this, if I write x plus y plus z, the most simplistic of a trivariate polynomial, because now there are three variables x, y and z. So this becomes a trivariate polynomial. So this is the first kind of classification, the classification of polynomials according to the number of variables. If the number of variables is 1, it is a monovariate polynomial. If the number of variables is 2, it is a bivariate polynomial. And if the number of variables is 3, then it becomes a trivariate polynomial. Let me tell you friends, this classification is not very important from the point of view of this chapter, but it is indeed important to know how different classifications are possible for a particular polynomial. So this is the first kind of classification. The second kind of classification is depends on the number of terms in a particular polynomial. So let us write that down, number of terms. So if I let's say write f4x, we are just giving different names to a particular polynomial. So if I write x square, that's it. If I just write x square, for that matter, if I even write x, just x, for that matter, if I write even y, only y, or y square, this becomes a monomial. Now why is that? Because it has only one term. So one term means it is a monomial. So this will be written as a monomial. After that, if I write another polynomial, let's say x cube plus 5. Now this becomes a binomial. Now why is that? Because this polynomial has two terms. Now as the word polynomial itself suggests, polynomial means more than one term. So monomial does not get classified as a polynomial as such, but for the sake of classification on the number of terms, one term means monomial, two terms means binomial, three terms means trinomial, and so on. So we learned here another kind of classification which depends on the number of terms. Now this particular polynomial here is indeed a trinomial. Why? Because there are three terms over here. But one thing to notice also is this polynomial can be also classified according to this classification and be called as a bivariate trinomial. Now why is that? Because it has two variables x and y indeed, and it has three terms. So according to this kind of classification, this polynomial is a trinomial, but it is a bivariate trinomial as well, because it has two variables x and y and three terms x raised to 4, 3y and 7. So these are the two kinds of classifications which I wanted to recap, which I had, as I told, you must have observed in your previous grades, but these are two basic classifications. But the third kind of classification is what is the most important, and that kind of classification is based on the number is based on the degree of a polynomial. Now what is the degree of the polynomial is what we are going to learn further, a very important and a very interesting thing. So focus here. We will write a polynomial. Let's write p of x. Now let's just use another alphabet in place of f. You can use any alphabet here. Just for the sake of the classifications here, we used f1, f2, f3, f4, f5 and f6, six different kinds of polynomials here we learned according to the classification. The third kind of classification, as I told you, which is the most important one for this particular chapter of quadratic equation, and that depends on the degree. Now to understand what this term degree is, let's take a general polynomial, and that we will write as such: px is equal to an x raised to n plus an minus 1 x raised to n minus 1 plus an minus 2 x raised to n minus 2 plus an minus 3 x minus 3 x raised to n minus 3 and so on. A1 x raised to 1, so we can just write that as x because anything raised to 1 is the same number, plus A0 or A0 x raised to 0, and x raised to 0 is nothing but 1. So this is a general polynomial, the most general polynomial. One thing that we need to understand is, from the basis of this particular classification of the number of variables, this particular polynomial is a monovariate polynomial because it has indeed only one variable, which is x. And from the point of view of this has n terms as of now. The number of terms depends on the coefficients. Now coefficients are these values, an minus 1, an minus 2 and so on. These are the terms or the values which lead all these x raised to n, x raised to n minus 1, x raised to n minus 2 and so on, all these terms. So first of all, let's focus on the term degree. Now degree here, for this particular polynomial, the degree is n, and n is nothing but the highest power that x takes in this particular polynomial. So as you can see, n is the highest power that x takes in this entire polynomial, because then we have n minus 1, which is indeed less than n, then n minus 2 again less than n and so on. And here it is, the power of x is 0, here the power of x is 1. So the highest power that x takes in a polynomial is called the degree of a polynomial. So we can say that degree is nothing but, by definition, highest power or the highest exponent that x takes. So highest power of x is what degree is by definition, and we write that as n. The necessary condition on n is that n has to be necessarily greater than or equal to 0. It cannot be a negative number. We'll see as n changes, how does the polynomial change. We'll see that in the next slide. But first, let's try and understand that how and let's try and understand what are the different conditions that are applicable on this polynomial. The first and foremost important condition is that all these coefficients an minus 1, an minus 2 and so on till a1, a0, all these coefficients have to be real numbers. So we can write that as such. This signifies that all these values, all these coefficients of these terms in this polynomial are part of the real set. So we sometimes write this as such. So this signifies the condition that all the coefficients of a polynomial are real values. Another condition is the degree has to be a whole number greater than or equal to 0. This has to be an integer. So another important condition on this is n has to be greater than or equal to 0 and n needs to be an integer. So the basic condition we can write is n is a part of w, w representing whole numbers starting from 0, 1, 2, 3, 4. It cannot be a decimal is what this particular thing says, and x is the variable as we already discussed. So this is a monovariate polynomial. But as we are talking about degree, as n changes, the degree of this polynomial changes. So if n is 0, then it is a constant polynomial. If n is 1, then it becomes a linear polynomial. If n is 2, it becomes a quadratic polynomial and so on. Now these different things we are going to learn in the coming slide. Now friends, as I said, we'll learn more about this particular classification of polynomials, which is based on the degree of the polynomial. Here we understood what the degree is. Degree is nothing but the highest power of x in that particular polynomial. Now, if n changes, let's start with the very smallest value of n, which is n is equal to 0. As we learned, n is an integer, n is a whole number, and n naturally has to be greater than or equal to 0. So basically n can take values from 0, then 1, then n can take value 2, 3, 4 and so on, right? So when n is equal to 0, how does this particular polynomial look? When n is 0, there is naturally going to be only one term, and that term is going to be this constant term. Try and understand, if n becomes 0, all these terms are not there at all. There is only one term, which is a0 x raised to 0, which is indeed this term over here, and hence the polynomial is going to look like this. F of x or p of x is equal to a0 or a constant term. So px is equal to constant is how the polynomial is going to look like, of degree 0. So we will call this polynomial of degree 0. The next value of n, which is n is equal to 1, will make this polynomial look something like this. Now when we substitute n as 1 here in this general polynomial, we are going to have a1 x raised to 1, then a0 x raised to 0. There are going to be only two terms, and we can write this as ax plus b. So just to have different alphabets, different coefficients, I am writing a1 as a and I am writing a0 as b. So now this particular polynomial is called as the linear polynomial. So this is the polynomial of degree 0 called as the 0 polynomial. This polynomial is the linear polynomial of degree 1. So we will say degree 1 and we call this a linear polynomial. Now further, the next value of n is 2, which is the whole agenda of this chapter. When n is equal to 2, this particular polynomial is going to look like this: a2 x square plus a1 x raised to 1 plus a0 x raised to 0. So basically the constant term. So now as you can understand, when n is equal to 2, there are three terms: a2 x square plus a1 x raised to 1 plus a0. So now we will write a2 as a, so this becomes ax square. Then we will write a1 as b, so this becomes bx, and lastly we will write a0 as c. So this becomes a quadratic polynomial, and as I said, the whole agenda of chapter revolves around this particular polynomial of degree 2. So as I said, we will call this a quadratic polynomial. Now after this, when n is equal to 3, px is going to look like this: ax cube plus bx square plus cx plus d, and when n is equal to 4, px will look like ax raised to 4 plus bx cube plus cx square plus dx plus e. So now I hope you have understood how this is going to proceed when n increases its value. Here we have n is equal to 4 and further it proceeds as such, and from the name point of view, this particular polynomial is called the cubic polynomial because the degree is 3, and this is called a biquadratic polynomial because the degree is 4. So this is how the general polynomial is translated into different types of polynomials on the basis of the classification of degree n, where n, the degree of a polynomial, is nothing but the highest power, the highest index that x takes in that particular polynomial. Now after understanding the classification of polynomials as such, and as I have emphasized again and again that this is where we are going to discuss everything. So basically this quadratic polynomial is something which we are going to emphasize more on. But before proceeding to that, let's talk about roots of a particular polynomial and the relation between a polynomial function and a polynomial equation. So as I had said at the start of the chapter, that equation means equating to a particular value, to a particular number, and generally that value is 0. Now why is that? Let's see. Here if I say for this particular linear polynomial, if I say px is equal to 0, which clearly suggests that I'm equating this linear polynomial with 0 so that we can find the roots of this particular equation. Now px is equal to ax plus b is called a linear polynomial, and px is equal to 0 for this particular linear polynomial is called as the linear polynomial equation. So now when I say px is equal to 0, it indeed becomes ax plus b is equal to 0. Now why is that? Because px is equal to ax plus b and we are trying to find out the roots for this particular equation. Px is equal to 0. So ax plus b is equal to 0 will have the root as x is equal to minus b upon a. It's quite simple to understand, right? B goes on the other side, then a comes down, it becomes x is equal to minus b upon a. So we understand that x equal to minus b upon a is the root of the linear equation, linear polynomial equation ax plus b is equal to 0, or you can write p of x is equal to 0. So two things that we understand here is, first of all, the difference between a polynomial function and a polynomial equation. A polynomial function looks like this, and when we equate it to 0, so at this stage, let me tell you one thing, we can equate this to some constant as well. We can equate this to 5 as well. We can equate this to 1. We can equate this to 3.5 or any particular constant. Why? Because when you equate it to some constant, that constant value can come on this side and then merge with the value of b, and again your right hand side will become 0. So try and understand this, equating a polynomial with any value need not necessarily be 0. It can be any particular constant. That constant goes on the left hand side and again makes the right hand side 0, making the equation look like this. Ax plus b is equal to 0. Naturally the value of b will change once we have a non-zero value on the right hand side. So it looks like this, a linear equation now, for which we can find out a root in this case, which is x equal to minus b upon a. And the second thing that we learned here is, for the polynomial equation of degree 1, we have one root which is x equal to minus b upon a. Now this emphasizes the fact that any polynomial equation of degree n has n roots. So let's mark this particular concept. A polynomial equation of degree n has n roots. We are not discussing about the nature of roots as of now, but in general we now know that any polynomial of degree n has n roots, and this is how we calculated the root of the linear equation. How will we find out the roots for this particular polynomial quadratic equation? We are going to learn in the coming slides, but for now let us just write down the quadratic equation for this polynomial, and that is going to be ax square plus bx plus c is equal to 0. And as I said, this 0 can be some other value as well, some other constant as well, which can come on the left hand side and merge with c, obviously changing the value of c, but again we will get a 0 on the right hand side, and this, my friends, is called a quadratic equation. This here is a quadratic polynomial or we can say ax square plus bx plus c as a quadratic expression as well. But when we talk about an equation, a quadratic equation is of this form: ax square plus bx plus c is equal to 0. And this is going to be the most important thing for this particular chapter. Now in the coming slides, my friend, let's just discuss a few more things from the previous grades. As I said, being the remainder theorem and the factor theorem, a few divisibility techniques, and then let's dive into the most important thing: how to find out the roots of a quadratic equation which looks like this: ax square plus bx plus c is equal to 0.